This one obviously needs some work because you haven't written much. Question mark. So first of all, I was thinking we're getting towards the end of the paper. Maybe your timing, like we talked about last time. But then I looked at question 13 and question 14, and they're nice and clean. They look like you're still confident and, you know, in control at that point. So we can talk when we meet up. We'll talk about the timing and what strategies you used. But this one I think is just a really hard question. With any statistics question, which is going to be binomial or normal, or about a probability distribution, I know everyone hates doing this, but I really recommend trying to work out what x actually is and then thinking about how x is distributed. Now in this one, it's really hard to work out what x is, and I think that's why this is a hard question, because the thing that we need to unlock it is really obscured. So after reading it a few times, I think this is going to work. X is the number of children, so that's people aged 5 to 17, from population size. I'll come back to this, what this size is, n. So we're taking n people, and for each person we're saying, are you or are you not aged 5 to 17? If yes, they go in that pile. If no, they go in that pile. And then x would be distributed binomially. N would be the size of the population, because that's everyone that we are testing. And then p would be the proportion of people who are aged 5 to 17 out of the population. It's the probability of me getting somebody who is that age group from that whole population. Now in the UK, out of, and this is what you were doing here, out of 56,075, whatever that number is, this many were children, which means that the proportion of children in the UK who are children, the proportion of humans that are children is 0.1511, blah, 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 like 15%. That's what we found there. So in the UK, P equals, I should put a colon there really, UK, P equals, I'm going to go with your one, I haven't actually checked that, but let's say that's correct. Now, somebody else says, I think that in another country, the proportion is different. So what we have here is a hypothesis test. Now you can kind of tell that from the it found evidence 2.5%, blah, blah, blah. You know, it's phrased like a hypothesis test question. But actually, even without that, I think we can tell that it's a hypothesis test question. So we have H0 colon, H1 colon. The historical data, or the data in the UK, the thing we're comparing to, is that P equals 0.1511. And we are doing OCR, so we must say what P is. P is the, I'll pause it while I write it, it's a bit boring watching me write. Okay, so P is the proportion of children aged 5 to 17 in the population. This is going to get you a mark in OCR. And so then that's H0, the historical information, the UK information that we're going to compare to. H1 is the person that is looking at the proportion of children in this other country. And what are they saying? Are they saying it's different or higher? It was found that there is evidence at the 2.5% level that the proportion of children was higher. Okay, so they are saying, yeah, in order to conclude that the proportion is higher, we must have been claiming that the proportion is higher, not just changed or different, but like higher. So H1 person is saying that they think P is bigger than this, and probably 3 significant figures is fine. We weren't told to use more than 3, so 3 should be fine. Okay, so what do we do next? We've got H0, we've got H1. Now we take our sample that H1 thinks proves them right. So the sample size that we've taken in this case is 10,000. Yeah, the other country, yeah, 10,000. So the binomial that we're actually looking at here is a proportion of, no, n goes first, a sample size of 10,000, and the claim the historical data is that P is in fact the same as the UK, 0.151. X is binomial NP. Now we do the survey, we ask the 10,000 people and we get the result. Now we're not told what that result is, but we're given a result. So let me just draw my little picture. So here's the binomial distribution, binomial 10,000, 0.151. This is 10,000 and at the other end 0, 1, 2. Somebody did a survey and the result that they got, M, the number M of children, yeah, so the result that they got was M, and we don't know what it is, but we do know that this area has come out smaller than 2.5%. Because if it had come out bigger than 2.5%, and that's the significance level for our test, and our area was too big, then we wouldn't reject extra naught, and we wouldn't have evidence at the 2.5% level. But apparently we do have evidence at the 2.5% level, which means that that area there is less than 2.5%. Okay, now we have the problem of, okay, well I know the area to the right, but I don't know the M, so I need inverse binomial, right? But there is no inverse binomial in the specification, so we can't do it. You could do trial and error. You could sit there for 10,000. You could sit there for ages going, what about if it was 9,000? What about if it was 8,000? What about if it was 9,510? What about if it was... So you could do that for ages and find the exact M integer where the area to the right of that is less than 2.5%. You could do that, but what's going to be a lot easier is if we use a normal approximation. Now where's the clue in the question that that's what we were going to do? Oh, it's at the bottom where it says use an appropriate normal distribution to find an estimate. I was going to say you will see the word estimate or approximate, but actually not only did they say find an estimate, they also said use the approximate normal. So what we're going to do is find out what this normal distribution is. And then it's going to be the exact same question. We'll know the area to the right and we want the number, but we will be then in a normal distribution situation, which means we can use inverse normal on our calculator. So happy days. So what do? We have to change the distribution from binomial to normal. I shouldn't really use, it is the same x is distributed approximately normal, and then the first thing, the mean, you multiply those two numbers together, so the mean is NP, and then the standard deviation is the variance is NP times 1 minus P. Okay, so now I've got the normal distribution. I can go in the calculator and I can go to the menu for stat and then do inverse normal. Now the inverse normal button on here won't do to the right. I have to tell it the area to the left. So if the area to the right is going to be less than 2.5, then the area to the left is going to be more than 97.5. It's going to be more than that, so that the area to the right is less than 2.5. So you would go into a calculator, inverse normal, area to the left equals 97.5, and then put in the mean, put in the standard deviation, and then see what your calculator says for M. I'll give it a go and see what it says for me. So I get 158.199. Don't forget, this is the variance, not the standard deviation. It's the standard deviation that you put into the calculator. So I get that, but that's not going to be the right answer because it says find the smallest possible value of M. M cannot be a decimal. M was the number of kids in the sample, so it can't be a decimal. So the nearest integer that it could possibly have been is that. Now, if M was 1581, is that area to the right less than 2.5? I used exactly 2.5. I used exactly 97.5 on the left. So at this stage, I am not 100% sure that this is the right number, but now I can do that simple trial and error with the binomial distribution to see what works. I don't know whether it's only 5 marks. I think I've probably already done 5 marks worth of stuff, but I would want to do that. I would want to then check. So I'm just going to grab the calculator and use the binomial and see what the area to the left and the area to the right are for that particular m. It worked. It was fine. So here's our binomial distribution. We know that the number that we found, the m, when we found that probability to the right, it came out less than, oh no, I haven't come out less than. I've come out very, very, very close to 2.5%, but I haven't come out less than. I've come out slightly bigger than. 0.02500493352, slightly bigger than 2.5%. So unless the question had said near 2.5%, the way that it's phrased, I would have to be less than 2.5%, and I am not. So what I'm going to do is I'm going to try again with one bigger. So I'm going to go to the calculator and I'm going to change that to 1582, which would mean that in the calculator I need to put 1581 because it only does less than or equal to, and then I'll see what that number is and then I'll check back in. Okay, now it works. I got a probability to the right that is less than 2.5%. So actually this one didn't quite work, but this one did work. So I reckon that's the answer.